video contains some practice exercises in calculating GDP, both nominal and real GDP, using two different base years. And there's a demonstration of how to recalculate a price index by changing the base year, which has been a popular question from students in the past. Up in the left-hand corner here, this is done on an Excel sheet, so there's letters across the top, numbers across the left side as cell references. There's a grid of prices and quantities. We've got two products here. We've got product A and product B. And in 4 years, we have the price of product A, 8, 10, 11, 11, quantity of product A, and then price of product B and the quantity of product B. Using those numbers as your first exercise, calculate the nominal GDP in the 4 years, and then calculate real GDP using year 1 as your base year. So you'll use the prices 8 and 32 for all of your quantities. And then calculate real GDP again using year 3 as your base year. So your prices for every multiplication will be 11 and 35. I will pause for a second, pause the video while you calculate those, and I will reveal the answers in a bit. And here are your answers. A couple of observations you can make that always have to be true. Your nominal GDP in year 1 is calculated using year 1 prices and year 1 production, and your real GDP is using year 1 quantities and base year prices, and since the base year is year 1, nominal and real GDP are the same. And the same would be true with real GDP using year 3 as your base year. Nominal GDP here is year 3 prices times year 3 quantities, and here this is base year prices times year 3 quantities, but since the base year is year 3, we see that nominal and real GDP are equal. Using these numbers, these 12 numbers, you can calculate the GDP deflator as a ratio of the correct two of them. So calculate that price index or the real GDP deflator for all 4 years using years 1 and year 3 as your base year. Again, pause the video while you're doing that, and I will reveal the answers in a second. So here are your values for the GDP deflators. Remember that these are price indices, so they're measures of price changes from one year to the next. As an interpretation, let's look at the deflator for year 3 using year 1 as the base year. That value of 117.5 means that prices in year 3 are 117.5% of what they were in the base year in year 1. And that also means that between years 1 and 3, prices rose by 117.5%. That's your inflation. Inflation rates are always calculated by dividing, not by subtracting. And as another example of that, we can look at how much prices went up between years 1 and 3 using a different year as the base year. And since they're both measuring changes in prices, the answer should be approximately equivalent. And this is true. If we calculate inflation using the deflators over here, with year 3 as the base year, the amount of inflation between years 1 and 3 would be 100 divided by 85. And while it's not exactly equal, we do find that that deflator, or those measures of the deflator, still indicate that prices went up by about 17.5% between years 1 and 3. Now, as a more complicated exercise, we can recalculate the price indices using year 3 as the base year. So suppose we don't know them. Without knowing the information about the prices of the products and the quantities of the product, which means we shouldn't know the values of real GDP. And you might ask, why would we ever need to know this? Well, if we pick a particular year for the base year and use that same base year for a period of 20, 30 years, something like that, and economists did this for a long time. They used 1980 as the base year for a long time calculating GDP. But then 20 or 30 years later, you calculate GDP and you get a deflator of 250, and because there's been so much inflation, you get values of real GDP that are something like 5, maybe 6 trillion, when nominal GDP is 16 trillion. And the value of real GDP of something like 6 trillion really doesn't give you a very good sense of how much stuff is being produced in the economy. So to adjust for that, you change the base year from 1980 to, I think, 2005 is what's being used now. And you don't have a record of the prices and the quantities of the things that were being sold in those past years. You may, however, have a record of the nominal GDP in those years, and you'll have the deflators for all of those past years. Using that information alone, you can recalculate real GDP using your new deflator, and you can calculate the deflator itself. The trick to recalculating the deflator using a different base year is to recognize this observation that we made earlier, that it doesn't matter what the base year is, the value of inflation that we're capturing should be the same. So before, when we used the first year as the base year, we found that between years 1 and 3 there was 17.5% inflation, and we found almost exactly the same amount of inflation when we used a year 3 as the base year. Now, it won't be exact, so it will be an estimate, but it will be very, very close. And what that means is whatever value we choose for these deflators in years 1, 2, 3, and 4, we know that the deflator for year 1 should be about 17.5% less than the deflator in year 3, or the deflator in year 3 should be 17.5% more than the deflator in year 1. We can use that same sort of logic to calculate the ratio of the deflators between years 2 and 3 by looking at the ratio of the previous deflators in years 2 and 3. And then again, the ratio of the deflators between years 3 and 4 should be the same ratio of our new deflator between years 3 and 4. All we need is a starting point. And we know that if the base year is year 3, the value of the deflator in year 3 must be 100. So we can use that knowledge that the ratio of corresponding price indices has to be equal regardless of which year we choose as the base year. That's to say that the ratio of this number to this number has to be equal to the ratio of this number to this number. And that's set up in a relatively simple equation over here. So 117.516 divided by 100 is 1.17516. That has to be equal to 100 divided by x. And with a little bit of cross multiplication, pause for a second. I calculate that to be 85.095. So that's the value of our new price index in year 1 when year 3 is the base year. And because we calculated it to be this, it is true that the index in year 3 of 100 is about 17.5% larger than the index in year 1. We can use that same sort of logic, that the ratio of this index to this index has to be equal to the ratio of this to this. We can use that to solve for that blank. And going either direction, the ratio of this to this has to be equal to the ratio of this to this, or you can divide in the opposite order if you want. That 120 divided by 117 has to be equal to x divided by 100. I'll pause for a second. I will reveal those answers, and that'll be the end of the video. And here come your final answers. The new index using year 3 as the base here. For year 2 is 87.16. And for year 4, I calculated 102.277, 0.28. So a nice way to check your work is to verify that when these numbers went up by a fairly small amount, these numbers should go up by a fairly small amount. And remember that it's not the difference. This went up by about 2.5. This went up by less than 2.5. But this is about 102.4% of what this was. It's ratios and not differences. And down at the bottom here, if you ended up with the number like 97, it means that you got your fraction backwards, put the wrong number on the top. Because this number went up slightly from 117 to 120, this should be a couple percentage points higher than 100. And my numbers indicate that. Okay, good luck.